This next problem is very, very similar to the last one. So if you're feeling relatively confident with limiting reactants, you've tried a few in the homework, you feel like you're getting them right, you can totally skip this if you'd like to. But if you're somebody that's saying, you know, I think I just need to walk through another one, make sure I got my ducks in a line, then this would be for you. But you really can skip this problem if you are not having trouble with limiting reactant problems. We have the balanced equation, a single replacement between silver nitrate and nickel. We have 22.9 grams of nickel and 112 grams of silver nitrate. How many grams of silver can be formed? Okay, so we said first step, we need to figure out if there's a limiting and excess reactant because that's the one that determines the amount of product formed. We can't work in grams, so we need to get these in moles. 22.9 grams of nickel. Get it out of grams into moles. 1 mole should have the molar mass on the periodic table, 58.69 grams. So plug that in. I'll leave 3 sig figs. 390 moles of nickel. All right. We do the same thing with the silver nitrate. 112 grams of silver nitrate. We want it out of grams into moles. So we'll just add this one up. Nitrogen, 3 oxygen, and 1 silver for a total of 169.88. 88. And in moles, I'm about 0.718 moles of silver nitrate. All right, cool. So now let's look at this one in a little bit, maybe a little different light than the last one. The last one had, I think, a 2-to-3 ratio, and we weren't quite sure. The amounts that we had were maybe kind of close. So we did a little calculation to justify our answer in determining which was the limiting reactant. Maybe this one we can do without a calculation. It's an easy ratio. It's a 2-to-1. I'm supposed to have twice as much silver nitrate as I do nickel. So maybe I could do this one in my head, that if I take this nickel, I'm supposed to just multiply by 2 to get the amount of silver nitrate that I need. Well, these aren't super crazy numbers. It's not a super crazy ratio. So, I mean, I could kind of do that in my head, or I could estimate times 2. So I need approximately 0.8, or exactly 0.78 moles of that silver nitrate. So I didn't do a huge calculation. I can kind of estimate, or this one I can multiply by 2 in my head. I need about 0.78. I'm just shy. These amounts are what we have. The amount of nickel, the amount of silver nitrate that I have to work with, I do not have that much. I'm close, but silver nitrate will be my limiting reactant, leaving nickel as my excess. This makes a little bit of sense. Silver compounds are expensive. So if you are working with a silver compound, you wouldn't want that to be your excess, because then there's often just some kind of wasted compound in the end. So in this case, we're going to react all the silver nitrate and turn it into silver. Okay, so I got my limiting reactant. I think we can run with this. We're going to go from silver nitrate to silver. So we set it up. We're going to start with the amount that we have, 0.718 moles of silver nitrate. It's always the limiting reactant, and it's always back to the amount that you originally had, not what you need. Since it's in moles right away, I kind of took a little shortcut and used this number in moles. We can cruise. We can cancel moles of silver nitrate, and we can turn it into moles of silver right away. Which, I get it. It's a 2-to-2 ratio, so it's not going to change my calculations. But I like it, because it sets up my units in the right spot. And now finally, we're probably going to want this back in, grams. So we'll cancel moles of silver. We want it in grams. We'd really measure it in grams. 1 mole of silver on the periodic table, 107.87. Oh, nice. Moles are gone. We can plug this in our calculator, and we've got grams of silver formed. See, these aren't so bad. You do have to switch your original amounts from grams to moles, but then just do a little inspection. Look at the mole ratio from the equation. Look at what you have. Sometimes it doesn't require some fancy calculation. You can kind of just do it by inspection. Okay, 77.5 grams of silver formed. Cool, done. That wasn't so bad. The second part of this, in terms of the excess reactant, with these amounts, how many grams of the excess will be left over after the reaction has gone to completion? And again, a couple ways that you could do this. You kind of have to think about it as two parts. First, how much of the excess gets used? Second, how much is left over? The limiting reactant determines how much of the excess gets used. So I'm actually going to set up something that looks really similar to this last stoichiometry. We're going to start with the limiting reactant, 0.718 grams of silver nitrate. But this time, instead of switching to the product that we're looking for, we'll switch it to the excess reactant, the nickel. There we go. So we'll cancel, oopsie, that's not grams, that's moles. Get out of there. Moles. There we go. Cancel moles of silver nitrate. And let's get this over to moles of nickel. And again, this was the limiting reactant, just like above. The ratio from this equation is 1 nickel for every 2 silver nitrate. Now, in the last problem that we did together, I stopped here at moles. You can do that totally fine. Figure out how many moles gets reacted. Or if you'd like, you can turn this into grams right away. You can cancel moles of nickel and switch it to grams of nickel. 1 mole should have the mass on the periodic table, which was 58.69. So you could plug this all in your calculator. Everything should line up. Moles and moles cancel. I'm out of silver nitrate. I got over to the nickel. Moles of nickel cancel, so I'd be at grams. If I plug this in with about 3 sig figs, 21.1 grams of nickel. That's the amount used, the amount that gets reacted. So now all I have to do is subtract that from the amount that I originally had. So originally in the problem, let's see, what were we given here? Nickel 29 or 22.9. That's the amount that I have. I'm going to use about 21.1 grams. Or you could say reacted. So the difference is just excess. About 1.8 grams of nickel excess. And now you could also do it like the last one, where we could have done the subtraction in moles. Moles of what we had minus moles of what we used would give us moles of excess nickel. And then we could switch it from moles to grams. It really doesn't matter. So pick whatever works best for you. But these are real typical limiting reactant problems. So hopefully these start to catch on for you. And again, if not, stop by. We'll need to have a little intervention time. But I'm hoping that it rings a bell. It should be something that you've done in the past.